So, okay, so you've spoken about, and the level of curiosity of previous civilizations that we've had, ancient civilizations that we've had, some even, humans were around far longer than scientists say. 300,000 years ago, the Jebel Irhoud, Morocco. I don't know if you've read into that or you've read that or not.
Yeah,
There's a lot of weird stories that people claim, right?
Yeah.
But for me, the possibilities of an extinction event, that can happen. What are some different forms of events that can happen for us to be extinct?
Well, okay, the event that happened 12 to 13,000 years ago, called the Younger Dryas, is the most recent extinction level event in Earth history. Younger Dryas was sort of what bookended the Great Ice Age. And the ice had started warming and melting around 15,000 years ago. And then at 14,600, there was a gigantic meltwater pulse. It's called Meltwater Pulse 1A. And then at 12,000, just a little less than 12,900 years ago, was what's called the lower Younger Dryas boundary. Okay, there's Meltwater Pulse 1A. There it is right there. If you go down, Meltwater Pulse 1A is also known as a catastrophic rise event. The rates of sea level rise associated with Meltwater Pulse 1A are the highest known rates of post-glacial eustatic sea level rise. Meltwater Pulse 1A is also the most widely recognized and least disputed of the named post-glacial meltwater pulses. Now, since this was written, I think a lot of the evidence of the last couple of years confirms that the rise of sea level, because of the melting of the glaciers, was pulsed. It wasn't a smooth, uniform curve. And I think that there was a meltwater pulse at 14.6, and I think that's what that's showing right there. There was another meltwater pulse at the lower Younger Dryas boundary, about 12,900, and then the third one was at 11,600. And those are all related to very rapid acceleration of ice sheet melting. Because when the term eustatic that you just saw there is a type of sea level rise or fall, a change in the vertical elevation of sea level correlated or corresponding directly to the amount of ice on the land surface. So the greater the amount of ice, the lower the sea level. And as the ice melts, then sea level rises. If we were to go into another ice age, then sea level would fall again until the planet, there we go, yeah, when the amount of water stored in ice caps changes, it can cause sea levels to change. This is called glacial eustasy. For example, after the last ice age, global sea levels were about 130 meters lower, which is actually more than 400 feet. But the glaciated regions were depressed by at least that much. Yeah. And it gets into some complicated stuff. Isostasy is the vertical movement of the Earth's crust. They don't use that term there, but there was a very, very significant change in the vertical elevation of the Earth's crust because of the deglaciation that occurred. If Rob, look up this term, isostasy, ISOSTACY. There we go, or STSY. The equilibrium that exists between parts of the Earth's crust, which behaves as if it consists of blocks floating on the underlying mantle. Rising if material, such as an ice cap, is removed, and sinking if material is deposited. So you've got these two connected processes, isostasy and eustasy. Isostasy is the vertical movement of the Earth's crust. Eustasy is the vertical movement of the ocean levels. And they're correlated because when you're building...
One goes down, one goes up.
Yeah, when glaciers grow, sea level drops. When glaciers shrink, sea level rises. That's it. And when that huge mass, you got to figure now, a lot of Canada was buried under 1.5 miles of ice. So what that does is it depresses the crust. Just like the analogy I use, if you're, like when I was on Rogan explaining this to Rogan, I said, right now you're sitting on a comfortable chair with a cushion, aren't you? And he said, yeah. I said, okay, well, right now the cushion you're sitting on is isostatically depressed. And if you were to get up, then the cushion comes back. So I said, Joe, right now you didn't realize this, but your ass is isostatically depressing. And I think he got it.
Makes sense.
Yeah.
So it makes sense on, I totally get that part. But going back to this, so, Okay, extinction event.
Good. Yeah. Okay, so we had an extinct. Now, it's not considered one of the Great Five in Earth history. Now, the Great Five, you're talking about 3/4 to 95% of all species, marine and terrestrial, being annihilated. Now, the two primary candidates, I think, are one would be impacts, two would be gigantic volcanic eruptions, and three that now needs to be considered, I think, is solar outburst activity. I don't want to talk too much about that because I'm in the early stages of really kind of trying to understand the physics of the variable sun. But there does certainly appear to be times when solar outbursts have been, there they are. Ordovician, late Devonian, and Permian was the biggest one at 250. Now, MYA is million years. Think of it million years ago, but the A actually means annum, Latin for year, right? So 250 million years annum means 250 million years ago. So you've got, those are the big five: Ordovician, late Devonian, Permian, Triassic, and Cretaceous. Cretaceous is the most famous one because that's the, like it says, the event that killed off the dinosaurs. Now, that Cretaceous, I think was about, the estimates are 75% of all species on Earth went extinct. Now, the terminal Pleistocene extinction primarily focused on the top of the food chain, the large mammals. And I talked some with Tony about this. When I met with Tony and Rob the other day, I think we got into that a little bit. And there was this incredible megafauna in North America. I mean, it was Serengeti Plain plus. I mean, you had 3 species of proboscideans, which are basically elephants, living in unglaciated North America. You had giant camels. You had ground sloths the size of elephants today. You had beavers the size of bears. Yeah, look at, that's probably Jeffersonii. Let's see what, that's not the biggest one. Let's see what that would be. Well, that's one of the ground sloths, but there were multiple species. What's that there? That's the...
Just click on it, Rob, so it can show the 8. Go ahead, yeah. So the giant short face bear.
Now that guy, you would not want to encounter that guy on a...
He looks friendly.
You figure that guy, when he stood up on his hind legs, a full-grown one, was 12 feet tall.
Damn.
Now, the megafauna at the end of the Ice Age was just, the saber-toothed cat or the scimitar cat. Again, they were here in North America very abundantly. What else we got there, Rob? The direwolf. Now, these guys, they hunted in packs. Their jaws were like twice the mass of a modern timber wolf. When you think about it, like when we get up in the morning, mammoths and mastodons. Mammoths were grazers. They liked open areas. Mastodons were browsers, so they were in forested areas. Giant ground sloths.
What is that? Giant beavers.
Yeah, Asteroids with a giant beaver, camelops. Yeah, so all of these guys are gone. What happened to them? Well, they all disappeared within a very short window of time, and the peak of the extinction, actually, if you go back to about my slide number 5 or 6, I have what's called it's a mortality graph. This goes back 50,000 years. And each of those squares, black and white, represents the finding of a fossil of an extinct mammal, megamammal. And what you see there is that right when you get to around 14,000 years ago, it starts trending upwards. When you get to the Younger Dryas, it peaks, and then it tapers off. So what that means is that the number of fossils found in the record of these extinct mammals peaked right around this time when you had these tremendous changes that were going on, temperature changes and so on. So the loss of species is going to be directly a function of habitat destruction, because that's the main thing that causes species to go extinct.
Now, one may say of these 5 events that you talked about, the most recent one was 65 million years ago.
Yes.
Right? So, the average person right now, or even, say, you get a call and you're working for the leader of the free world, okay, and they have a division that their job is to be prepared for a possibility of extinction events.
Yeah.
I don't even know if we have it right now in our government. I don't know if somebody's job is to do that or not. I don't know whose job that is.
Well, it was actually going to probably during the Trump years. There was talk. You know, I know Matt Lohmeyer pretty good, Lieutenant Colonel Matt Lohmeyer, and he was high ranking in the Space Force.
Matt Lohmeyer just texted me.
Did he really?
Literally 2 hours before you and I talked. Literally 2 hours before we talked, he texted me. He's going to watch. He's going to be like, "Oh shit, it's so funny you're talking about him. I just got a text from him at 2:13 today." I had Matt on before.
Yeah,
so
good man.
Was this part of his job? He is. Was it part of his job to find ways to protect against extinction events?
Well, if you consider that the primary instigator of extinction level events is impacts, which I believe is the case, then yeah, it certainly could fall to Space Force. Because, and Matt was very much apprised of that idea, and before he got canned for being politically incorrect, which pisses me off, I was going to do a presentation to Space Force talking about planetary defense. But then that didn't happen.
So you were supposed to be involved in this.
I was going to be involved.
Okay, so perfect.
Yeah.
Now that you know that you were one of the candidates possibly involved, okay, so one sits there and is like, you're talking to the president. All right, Randall, so let me ask you this. Well, one of my guys, research guy, tells me the asteroid that came in June 29, 2024, just a couple months ago, if it would have hit us, it would have been a pretty bad situation. Then you got the Tunguska event, 1908, Russia, when that hit, you know, and then you have the volcanic explosion, April 5th of 1815, which is the largest volcano explosion in human history. We're talking about Mount Tambora, right, located in Indonesia. Explosion was felt thousands of miles away. Volcanic winter, sunlight was blocked, causing temperatures to drop globally. Ash reaches as far as Europe. A year without summer, 1816. You've seen that before. You know about that. Or, you know, so we have the Yellowstone volcano caldera. Okay. All of these things, we put it on the wall in a, let's just say, decision-making room, whatever you want to call that room. All right. So how do you prevent from a meteor hitting us? How do you prevent from these volcanoes erupting? How do we, or is it just, guys, if it happens, you're screwed. There's nothing you can do about it.
Right now, yes. If it happens, we're screwed.
Okay.
We're screwed right now. But my interpretation of this is right now we're vulnerable. But if we get our act together, we don't have to, we can reduce our vulnerability enormously. Now, you know, and what are the potential? You just named several impacts, volcanoes. I think the sun needs to be included. The Carrington event of 1857, Rob's going to look that up for us. But we now know that there have been events.
Carrington event, you said?
Starting with a K, there it is right there, was the most intense geomagnetic storm in recorded history, peaking on the 1st and 2nd of September 1859 during solar cycle 10. It created strong auroral displays. Now, if that would happen now, I mean, it could really put down the electric grid that would take a year, a couple of years, perhaps even to restore.
Again, what was this? This was a
solar flare.
Geomagnetic storm.
Yep.
Recorded in history, peaking on 1st and 1859 solar cycle 10. It created an auroral display that were reported globally and caused sparking and even fires in telegraph stations. The geomagnetic storm was most likely the result of a coronal mass ejection,
the CME,
from the sun colliding with Earth's magnetosphere.
Magnetosphere.
Okay, to the average person, what the hell does that mean?
Well, it means that every once in a while, the sun throws off these gigantic blobs of plasma into space. It does it frequently, but typically those blobs are just flying out into space. But once in a while, one of those blobs will pass the Earth. And when it does, it can have consequences. And one of the things that it does is it can destroy ozone. It can allow galactic cosmic ray bombardment of the Earth, because normally the ozone acts as a filtering blanket that protects the Earth from cosmic ray bombardment. If the solar storm is intense enough, its own self can cause spallation of neutrons, and that creates beryllium-10 and carbon-14. Beryllium-10 gets preserved in ice cores. Carbon-14 gets preserved in plant matter, primarily tree rings, and we can then measure the amount of isotopes, beryllium-10, carbon-14, and determine the intensity of the coronal mass ejection. What we've found is that there is evidence of events minimum of 10 to 20 times more powerful than the Carrington event within the last 2,000 years. Now, obviously, we didn't have an electronic grid encircling the Earth upon which all of society was dependent back in the 700s or the 900s, but now we do. An event 10 times or 20 times greater than the Carrington event, that would cause havoc that could take a decade to straighten out. I mean, it would take down pretty much the electronic grid of the planet. There'd be no more computers. You'd have no more power coming out of it would be a disaster.
Okay. So
now, what do we do about that?
Yeah.
Well, there are ideas in place, but by people who've studied that dimension of catastrophe more than I have, of hardening the grid. And it would be expensive, but it would be minuscule compared to, say, for example, the money we've dumped into Ukraine. It would be, we could harden our electronic systems to withstand a Carrington-level event or even more powerful. Now, volcanoes, there the problem is you got ejection of sulfur dioxide and all these particulates into the atmosphere, which, like you just brought up, the year without a summer. Well, we could perhaps survive a year without a summer. We could. It all depends on how much, this is where preparation comes in. But something, say, even bigger than Tambora, which we know from Earth history has happened repeatedly, that's just in recent Earth history, since we've been keeping records. If we look at Toba, for example, it was many times larger than Tambora. But the point is, are we prepared? Well, what we would need, again, is lots of it. We would need a national stockpile of food. We would need backup generators, because we could literally maybe go a couple of years with drastically reduced agricultural output. We'd get through it because the atmosphere would clear out. Now, an impact event, like if we took the June 29th episode, that would have consequences that would take at least 5 to 10 years, probably, for everything to recover in the aftermath. But in that recovery time, you're going to the problem is you've got the first impetus, which is the impact itself or the volcanic eruption itself. Yeah. Then you've got all the secondary consequences and the feedbacks and things, so initially, like I said, with the impact of a 600 or 800 foot wide asteroid, it would instantly kill a few million people, depending on where it fell. If it fell in the ocean, now you're going to have tsunamis that make landfall that could be 200 feet high or more when they make landfall. So, I mean, you could have a tsunami that could literally wash over the entire peninsula of Florida. So you can see there, like if it fell in the ocean, it could probably kill more people than if it hit land. But if it hit land, now you've got all the debris that goes up, and as it falls
Very
back,
interesting. I got what you're saying.
Yeah.
So it's better it hit land and it hit water.
Yeah, probably so.
Okay.
In terms,
depending on where you hit, what.
Yes, and the other consequence of hitting water, of course, it's going to be like Hunga Tonga Hunga. It's going to throw all of this water vapor
we can't
into the
have
atmosphere.
That's a real situation.
Now, see, the thing is, there are studies now showing that impacts can induce accelerated and concentrated volcanic response in the Earth's crust, which makes sense. If you think if you got a major impact, it hits the Earth. And then look at the work of Michael Rampino. He's done some great stuff on this going back to the 70s, showing the correlation between impacts and volcanism. He's not the only one. There have been many others. Yeah, there he is. Yeah. I've been following this guy's work for years, since he was a young fella. And I was a young fella then too. But yeah, he's done a lot of work on the.
Let me be a skeptic here.
Please
just
do.
Push back a little bit and tell
Yeah.
So for me, okay.
In these uncertain times, if there's anything we need people to believe the future looks bright. So if you've heard about me saying this mission to you, we're on a mission to get 1 million people to wear this gear, and this is what we're doing. If you buy one of these hats, there's a category of buying one hat, getting the second one free. If you haven't yet worn this gear publicly, go ahead and test it out. Buy some of the gear, wear it in public, and see how many people will stop by and say, You also watch Valuetainment? You also follow PBD Podcast? I do too. Place your order. Go to vtmerch.com, click on the link above or below, place your order, and represent the VT and the PBD Podcast gear.
So if you like this clip and you want to watch another one, click right here. And if you want to watch the entire podcast, click right here.